Welcome to the Raman Lab of VB Department of Physics of VB Sanghas Veerashaiva College, Ballari. I am Miss A.Shirly Jones, Associate Professor and Head of the Department of Physics of Veerashaiva College. Today we are going to do a practical class for BSc 6th Sem students. The experiment what I have chosen today is FET, that is Field Effect Transistor. Now what is a field effect transistor? A field effect transistor essentially consists of an N-type material in N-channel FET, and here we have 4 terminals. First one is source through which the current enters. Here the current leaves via drain, and here we have 2 terminals. These are the 2 gates. And now these are made up of p-type material. Now this is called N-channel FET. Similarly, for p-channel FET, we will have N-type here, N-type here. This is a p-channel. This is current enters through S, current leaves through D. Now we can do 2 characteristics, or the aim of today's experiment is to draw the drain and transfer characteristics of FET. I have chosen this experiment to determine the pinch off voltage of FET. Now the circuit diagram to determine or to draw the drain characteristics or transfer characteristics of FET is something like this. What it has, we have FET, we have 2 power supplies. Now here there are 2 voltmeters. This voltmeter is VGS, this voltmeter measures VDS, and this is the current through the drain. Now really, to show an FET, every FET has got 4 terminals. Now there is a notch. Now beside notch is the first terminal, which is nothing but source. Next is drain. Next is gate. There are 2 gates, but I will use only 1 gate, so 1 I have bent like this. So let me come again. Source, drain, gate. This I will pin to a breadboard. Source, next is drain, next is gate. Okay. Now let us connect the circuit. Let me take first negative of the battery to negative of VGS. Now here it is negative of the voltmeter is coming to negative of the power supply and gate. So this is gate. I will pin it. Oh, this is gone. 1 minute. So here this negative and this negative, I will pin it here at gate. Yeah. And this is the other one. Okay. Next. From positive to positive of voltmeter. Here it is positive. It is connected to positive of voltmeter. Then it comes to source. So I will pin it at the source. Yeah. Next, from drain to negative. This is negative of what? Negative of milliammeter. So I will pin it at drain. Yeah. Next, positive to positive of the voltmeter and battery. Positive of battery to positive of the milliammeter to the battery, and also to positive of voltmeter. Next, negative of the battery to negative of voltmeter. Negative of the battery to negative of voltmeter, and the voltmeter negative to source. So I will pin this again at source. That's it. So here is the circuit. Now the circuit made. Now you have to check it again before you start with the experiment. Now I along the circuit. Okay. Now, to draw the drain characteristics, what we have to do? We have to keep VGS constant, vary VDS, note down ID. Let me come again. What we have to do? We have to keep VGS constant, we have to vary VDS and note down the drain current. First, let me keep VGS 0. Here it is, 0. Now I will vary the VDS. Now when I vary the voltage, increase the voltage, there is increase in current. But look what happens after some time. As I go on increasing the voltage here it's stuck at 12. That means the saturation point is obtained. Now second reading, what I'll do, I'll keep VGS 1 volt, and again now I'll start with VDS 0. Next I'll increase. Here also the current increasing, but look, it is becoming saturated at 8. Third reading, I'll make this as 2. Which one? VGS is equal to 2 volts. Now I'll vary VDS. Look what happens to the current. It is increasing and remaining constant at 4 milliamperes. So what's happening? What's happening when I make here 0 I kept, then it started increasing and it became 10 milliamps constant. Saturation occurred here. It increased. Next, when I made this 1 volt, it has somewhere around 6, I think. Yeah. And here when I make it 2 volts at 4, it stopped. So when I draw a graph of VDS versus ID for constant VGS 0, 1 and 2, I will get something, the graph like this. In the graph book we'll see. That means it will become saturated here only here. Here it will become here. Here it starts becoming here. So these points are shifting. So in order to determine the pinch off voltage, what we have to do is we have to drop a perpendicular at a point where it will remain saturated or constant for all the 3 curves. And here we will get something like constant, and for the FET I have done earlier, it will be there around 7 volts. Okay. Now let us do the second part. Now to do the second part, what we will do is, that is to draw the transfer characteristics. You have to keep ID constant or VDS constant. Let me keep around 10 milliamps. What is this? ID 10 milliamps. Now I will increase the gate voltage between gate and source. Look what happens here. The current decreases and you take the readings till the current becomes 0. Why this happens? This happens because I told you that when you increase, this voltage is VGS and gate is negative, I said, negative, positive, negative, positive, and this says VDS, so this would be positive, negative, positive, negative. So what happens when you keep VDS constant? Naturally ID here also will be constant, and when you increase this negatively, the width of the junction goes on increasing, and finally there is no transfer of current. That's why ID will become 0. So when you increase the negative voltage at the grid, then what happens at the gate, gate, then the drain current will be 0. That's what we see here. So we will determine what is the drain source shorted current, that is equal to somewhere around 10 milliamperes we get for this FET what I have used, and I have seen that at a VGS equal to some 6 volts we are finding the current becoming 0. So this is how the characteristics of FET are studied, and we have drawn both transfer, drain and transfer characteristics, and we have determined the pinch off voltage of FET. Now FET is a current controlled device, and every FET has got a pinch off voltage. This is how we determine it. Thank you.